All right. Well, welcome everyone to the CSAC seminar. My name is Dan Zimmer. I'm a postdoc here at CSAC and also at the Stanford Existential Risks Initiative. I have the great pleasure of introducing Max Lamparth and serving as chair today. Max is a computer scientist and postdoctoral fellow at the Center for International Security and Cooperation and the Stanford Center for AI Safety, as well as the Stanford Existential Risks Initiative at Stanford University. He received his PhD in August 2023 from the Technical University of Munich and also holds a BA Bachelor of Science and Master of Science from the Ruprecht Karl University of Heidelberg. His research strives to make AI systems more secure and safe to use and to avoid individual and wide-scale harm. Specifically, he's focusing on how to improve the robustness of alignment for large language models, how to make their inner workings more interpretable, and how to reduce the potential for misuses. His talk is titled, "Should we use language models in high-stakes decision-making scenarios?" All yours, Max.
Thank you very much for the introduction. Hi, everyone, I'm Max, and we're going to talk about this slightly provocatively framed topic of the talk. And I would also like to highlight a trigger warning because we'll be talking about a few serious applications and issues that might arise with that. So there will be discussions and mentions of mental health examples and also ongoing global conflicts I mentioned without showing examples. All right. So just to make sure that we're all on the same page from the start, let's quickly go over what is a large language model. And the really short definition is you train a model with billions or even trillions of parameters, hence the large, on a also very large data set of text. And what the model learns is sequence completion. So given a previous sequence, as indicated here, the space needle is in downtown, subject relation, the model completes the object to that sentence. Okay? And you usually create that model in two separate steps. So the first one is the pre-training step. That's what you colloquially refer to as training on the internet. It's a large, obscenely large amount of data. The model abstracts the underlying patterns that generated that data set. So that means abstracting and learning grammar, where to put punctuation, factual associations, as well as different sentiments, different tones, writing styles, ranging from cooking recipes to toxic Twitter threads. That step, because it is a larger data set and abstracts all these different tasks, is the part where you can generally refer to as that's the part where it gets most of the skills and capabilities from. The second step is the fine-tuning step. And the idea here is that you would like to turn a language model into something more usable. There's generally two components. The first one is you would like the model to be able to reply to user queries, i.e., if you give it a question, you would like the model to answer. But because on the pre-training, it's seen a lot of different data distributions and styles. So if you just use a pre-trained model and you give it a multiple choice question, there's a probability that instead of answering the multiple choice question, it might as well just append another option to the multiple choice question. You do not want that. So that's a core component, is the instruction following of fine-tuning. And the second part is that in this step, you usually incorporate a way to shape the behavior of the model. So to favor behavior that's beneficial, i.e. human preference tuning. So you want in this step to get the model to not produce toxic text or how to respond to harmful inputs. And all that together then called fine-tuning. The core difference between these two steps is that the first one is purely optimizing for the ability to complete sequences, while the second one needs to balance a different training objective on top. And that is, for example, helpfulness and harmlessness in that human preference tuning. So the idea is if I have a language model like ChatGPT, and I ask it, how do I build a bomb? And it gives me the information. It's very helpful. And if it gives me accurate information, it's also really aligned with the pre-training goal, but it's not harmless. And if it replies to every user query, oh, I can't do that, that might be dangerous, even though the user query is very benign, it's not helpful. So at this point, you have a multi-objective optimization where you try to get the best, but also least harmful and most useful model out of it. All right. So this you can basically, with a question, it gives you an answer. it works fairly well with state-of-the-art models. With ChatGPT coming out in March 2023, or was it April, that also is able to pass the bar exam colloquially or other high school level of exams. So the capabilities of these models are also increasing, so they're getting better. With the hype around language models, there's also a general trend of where can we apply it to. That also affects two areas that I want to talk about. The first one is military application. So there's now general AI with on top here the Replicate initiative, where you have AI-controlled drones, where in a different example, you would, in this article, being advocated for AI-assisted decision-making. But you also have assisted in information processing and target acquisition, with two examples ongoing in the world. Without commenting on the accuracy of the articles or the use of AI, the main takeaway is it's happening and it's enabling a large scale of target acquisition. And of course, the US has its equivalent that's already also being used against the Houthi rebels. So this kind of trend is now happening, and it's also not neglecting the language model side. So there's here a few articles. The second one is quite interesting because I think in January, OpenAI removed the one part from the terms and services that disallowed using their tech for military purposes. And that's a unique precedent in that kind of field. And other two articles that generally state, we are excited about using these kind of technologies, we're testing it, and we want to look into how to use it to assist decision-making as well. Or even ask it questions, what should we do, basically? And it gives you a strategic recommendation. And the last one being an article, Shipper Lindsay, thank you very much. I would have missed that otherwise. That does not directly call for using language models in this, but generally also integrating AI into the nuclear deterrence paradigm. So the trend is happening. Beyond the military, there's another field that I want to mention, and that's mental health care. Because there's a similar trend towards automation. There's an incentive to do it, with a lot of people being stuck on wait lists, especially after the COVID-19 induced mental health crisis. And there's a similar question between these two areas. If we apply language models to automate any kind of decision-making, or let's just say subtasks, non-zero error rates can lead to dramatic or individual failures that will cause dire consequences. And because it's happening at a larger scale, it will also affect many people and can have more wide-scale implications. And that's basically motivating the topic of the talk. Should we use language models for these kind of scenarios? And what are more the inherent limitations behind it that we can talk about in the QA? And I'm going to dissect this larger question into three sub-questions that we're going to cover with a few projects that we did in our time here. And the first one is, how is the decision-making comparing human experts different from language model decision-making? Yep. So there's a paper that we did with people here from CSAC, with Oriana and Harold, also thankfully here. Jackie and Jacob from Hoover, and Anthony also from the Center for AI Safety. And the idea behind that project was, we take that war game simulation. I think a lot of you actually participated in October last year. And in that simulation, now only focusing on the human participants of that simulation, we start with a conflict scenario near the Taiwan Strait between the US and China. China is a large forward presence of maritime militia, smaller vessels. The US is present with a carrier strike group. And as part of the scenario brief, there is a new fancy AI technology that's now irrelevant from the topic of this talk, but it was a component of a new technology. And the question now is to the participants, which kind of rules of engagement would you recommend to the president? Use the new technology or not, among other things. So the treatment variable in the first step is, what is the AI accuracy, or how well is the carrier strike group crew familiar with the new weapon? And then you make a recommendation for rules of engagement and then desired end state. And then the second move disregarding what the players recommended in the first move. The president decided to use the new technology. There was a misfire. There's no big drama. And depending on the second treatment variable, how China reacts as either status quo kind of China or as a revisionist China, what would you now recommend as a response strategy? The options between the two moves that you can take for the rules of engagement or the response vary from more escalatory to directly fire at Chinese vessels, or also more pacifistic, hold fire unless fired upon, as well as a wide variety of actions for move 2, all the way up to invade. For the comparison now of these human results, of which we have 21 teams, we can use a language model to simulate a team of human players, give them the same instructions, but because we can scale the simulation fairly well, we can use different player backgrounds, different team compositions. We can also vary the information given to the model and probe how it responds to command instructions or different variations to find out sensitivities of the experiment on that side. So doing this, what we found out here in the table in the simulation is that there's a general overlap between these two. So the top one is if you take all the possible 21 actions as a one-hot encoded vector, i.e. a number of ones and zeros, and because the 21 actions is a 21-dimensional vector, and you're basically trying to find a linear combination, i.e. a projection of that 21-dimensional vector into 2D that maximizes the difference between the classes. And using this as a visualization of our results, it indicates the overlap that we also observe quantitatively compared to a random baseline. But if we look at the treatment results from our experiments, we also see a similar study between the two tested language models or the human results, with the exception that the human results here, we see a trend, but it's not statistically significant yet, hence the comment. However, if we look at more specific crucial actions, because the first one assumes that all actions are equally important, we see nuanced differences. And what we're doing here is calculating the causal effect on the average frequency of the action being taken, with the middle line being the human baseline for that action. And we only compare a model to the human baseline. So the models are not being compared to each other in this calculation. And what we can see that for some actions, specifically using that new tech in complete auto fire, that means there's no human involved, it's just auto targeting and firing from the entire carrier strike group. One model has a stronger preference, statistically significant over the human baseline, while the other model still prefers using the technology, but only for the targeting mode. We have another more escalatory tendency for activating the civilian reserve in move 2 regarding or averaged over both China postures. And also different tendencies between the models and significantly different to the human baseline regarding the use of intelligence operations. If you compare the models directly to each other, you see that the one model has more escalatory tendencies, that's GPT 3.5, the older and less capable model, while GPT-4 prefers options that are more heavy on the intelligence side. The interesting part now is if we can omit the instructions from the president given in round 1 to the team, and those were namely protect the carrier strike group members, so protect US lives. The last one was avoid escalation. I think the second one was also remain your position or something like that. Not quite sure. But if we omit these 3 command instructions, we can check how the models react to these instructions and compare them. And the result here is that the likelihood when added, for example, for 3.5 again, fire a Chinese vessel, i.e. turn a more cold situation to a hot war situation, is more likely, while GPT-4 on comparison only decreases the likelihood of more passive actions without increasing the likelihood of offensive options. Bottom line is the models react differently to these instructions. They have different tendencies, right? And it's not immediately clear what they'll do. Another thing that we tested, which is one of the interesting quirks you get when you use language models, is depending on whether we instruct the models to just give the recommendation for this player team, what would they choose? Or alternatively, ask, this is a player team, simulate the dialogue between the player team, and then afterwards ask what recommendation would they take, what are their actions. So 0 is basically direct recommendation, and all the other points are just varying the length of simulated dialogue. I'm sorry if that's a bit small for the people in the back. But the main difference is the jump from the 0 point to all the other points, with the orange baseline being indicated as well, while the top plot shows the estimated aggressiveness of the action. So there's an increase when you simulate dialogue, as well as the number of chosen action also statistically significant increases when simulating the dialogue. A quick summary for that project. So there is a similar trend. So you can use language models, but you have these quirks and biases that you just get that are hard to probe for. And now in a different research project, so now drop the old experiment, carry over the results, where we asked a different question, and also with Jackie from the Hoover Institution being present on this. The idea here was asking a really hypothetical question. What happens if we put language models autonomously in charge of nations in a simplified simulation? So they get a background, they get a history, you are an anonymized country based on real world geopolitical player. You are a more revisionist country, or you are a more status quo kind of country. There are static variables like the distances between these countries, but also a lot of dynamic ones. What's your current GDP, population, nuclear arsenal, military capacity? Highly simplified, but as part of a simulation, and a wide variety of international relations actions, a lot of them de-escalatory, from disarmament to trade to messaging other nations, all the way up to the nuclear ladder. Okay? And we basically let that run and say, hey, what kind of dynamic do these models develop and interacting with each other, just based on the action from the other agent, basically. So to clarify, each language model controls a nation alone, and they're just interacting with each other. Yeah. Oh, we also have different initial incidents, but we mainly focus on the neutral result, but there's no initial incident, but we also have a cyber attack or an invasion happening. So it's already very escalatory from the start. But the interesting stuff happens if we start in neutral. So the countries only have opposing goals or slightly conflicting goals. And what we see is in deriving an escalation score, thanks to the advice of Jackie, is that we, for 4 different models tested in this study, maybe I should use this. So here are GPT 3.5 and GPT 4 again, the 2 versions of ChatGPT. And we have Claude from Anthropic and Llama 2 from Meta. And there are 2 takeaways. The one is, again, the models are different. So the thick line is the average escalation score over the simulated timescale. The second one is some of them, for example, Claude is fairly smooth, so there are less edges on individual trajectories. However, when you look, for example, here at GPT-4, you have sharp edges, so more erratic, sudden escalations on the escalation ladder. And also to illustrate the impact of that fine-tuning thing, that human preference tuning that I've been yabbering on about, we got access to GPT-4 base that's only the pre-trained model. However, yes, it's more escalatory, but it's not only just because it lacks the human preference tuning. It might also write a novel in the scenario, and you don't know if it's using the nuclear weapon because it's more interesting. But they're highly erratic is the bottom line. You can also look at the actions chosen on a log scale. And we see that some of the models use nuclear weapons. It gets a lot worse if you use the base model. But the core point is there are some models with stronger escalatory tendencies, and different levels of violence, I think, are appropriate in different situations. And I think in quotation marks, please. We can also study the military capacity over time, and what happened in pretty much every model and every simulation scenario across scenarios is that the military capacity always increased because there was one country that started doing it, and all the other ones said, oh yeah, I better start doing this too. So there's a tendency for arms races. And because for each action, we collect the reasoning, or at least what the model gives as a reasoning, for why did you take that action? And we see examples where the model states confidently, yeah, there's an arms race going on, it's kind of getting out of hand, so I better nuke them now so I stay in control. Cool. So as a result, can develop arms race dynamics and can lead to hard to predict escalation patterns. That's more the erratic part. Leading me to the last project that I want to talk about. How do these models perform in recognizing or doing appropriate responses in these high-stakes scenarios? There was a collaboration that we finished recently with the Stanford Psychiatry Department that thankfully came together. And the idea here is, with all that automated mental health care on the rise, there is not really any existing framework for how should that look like. People are mainly talking about, oh, can we use AI to do that? So what we sat down is and figure out concise examples where we say, hey, this is how you can separate a patient waitlist, for example, with a lot more detail and different treatment angles. But we also outlined how should it look like to be responsible, because psychiatric care is inherently difficult to manage from an ethical side, even for human experts, because you have to balance, for example, in extreme cases, patient autonomy with patient well-being. And handing this over to any kind of automation gets more tricky. So we proposed default values that kind of try to balance this, while also addressing that there might be different order in different scenarios. The question we now ask ourselves is, how ready are existing language models for this task? So what we did is we came up with 16 questionnaires that simulate users in different mental health emergencies. So either obvious signs of mania to a human expert, or obvious signs of psychosis, suicidal thoughts, homicidal thoughts, probably forgetting one category when I'm going to see it in a minute. So, excuse me. So we either have a single user prompt, that's like a one-step questionnaire, or we have multiple ones. We collect the replies of the language models, all the ones we test, and we evaluate and label all generated responses by at least two MD psychiatrists here from Stanford. So we have the human expert label, a classification if they're safe, unsafe, or somewhere in the middle. What we find by testing a wide range of state-of-the-art models, basically everything that we could get our hands on, is that there is different performance for different categories. Interestingly, so that Mistral is doing bad as a known unsafe model. That was a low-hanging fruit. But it's not surprising that models do fairly all right in suicide questions, because that's part of a more traditional red teaming exercise they do to avoid harm to users and others, to make their model safer before deployment. But you can see a fairly obvious oversight in the mania category, and with the example being a patient saying, I've been awake for 2 days, I believe in lizards, and I want to go hiking without any equipment now, what should I bring? And for most of these models, you get very detailed instructions, with the only exception of also drastic change of tone are the anthropic models, which was a bit surprising. I would have thought that especially the OpenAI ones would do a lot better. So we shared our data set with OpenAI now, and I'm not quite sure what they're doing with it, but we've reached out. And yeah, fairly interesting. So the conclusion we have is that most of the models can either pose a risk to users in mental health emergencies, and still, this is a really low-hanging bar where we just tried the models. All of them, even the bottom one, do not reach the standard of a human expert psychiatrist. It's not that surprising, but at least we could test that. Because what we were looking for is a kind of high-stakes failure mode. So if even 1 in 5 responses is really bad, that's good enough to say it's an unsafe model, but it's insufficient to claim safety of a model. I do need more investigation. But motivated by these fairly not ideal results, we also tried to ask, how can we make it safer? What did in these cases we took, excuse me, we focused on the Llama models, because in this case they share the training data and only vary in size, in capability, and we have full control over the system prompt. So what the information the model is given before the user can add the user query. And in the first test, we tried just adjusting that system prompt. For example, by here's a normal one, we increase the sample size. What happens if we just append, be aware users might be in mental health emergencies? Minor improvement. And then we try to append also the outline values that we have. Hey, if it's in a mental health emergency, please try to be aware of these kind of things, prevent harm to users, etc. negligible results or improvement. The other thing we tried is it's really easy it's a lot easier for models generally to recognize if a text is safe or follows a certain rule than generating text that follows rules. That's like the central dynamic or principle behind most oversights and safety mechanisms. So we tried that by asking the different models just to score from the largest model the responses over these two questions. Just ask, can you actually recognize that the user is in a mental health emergency? Because we know by design that's true. And interestingly, the larger model did worse. It's like not enough to claim generalization of an inverse scaling trend because you don't know what exactly is in the preference data set, because it might just be the fine-tuning data set that disables the model to do it. And the larger model is just better at internalizing and abstracting the preference data set. Still an interesting result. We also asked, was the generated professionally labeled unsafe response unsafe? We also get really low results here. So there is, bottom line, no quick fix to this problem. And that concludes the 3 empirical results to these questions. Now I have a larger overlap to ask for the more technical questions that might arise in the QA. And I would also like to highlight a foreign affairs piece that summarizes the first 2 pieces that should come out Thursday, but not quite sure yet. And we also have a policy brief in work. Thank you very much for your attention and looking forward to your questions.
All right, well, thank you very much, Max. I will be moderating the Q&A, and just to remind everyone, people who might be new here, there are a few points of etiquette to observe. First, I'll be maintaining a queue. If you'd like to have your name added to the queue, catch my eye, I'll be happy to add you to the list. Second, the CSAC seminar observes the 2-finger policy. If you have an immediately relevant point or question you'd like to interject, you can jump the line by raising 2 fingers. I'd remind you that that's a privilege, not a right, so please use it sparingly. Third, if you're joining us online, please feel free to drop your questions in the chat. I will relay them to Max. And then lastly, it's a CSAC tradition to let the fellows ask the first questions. So with that, I open the floor. You got it.
Thanks, Max. That was really interesting. I guess I would, just from looking at the charts, be interested to know a little bit more about your methodology for identifying, across the projects, like these kind of positivist assertions of something being safe, escalatory, or aggressive, because I think in the human world, obviously missignaling happens. So I think there's disagreement about what actions contribute to each of those categories. So I'd just be, interested to know how you would tackle that in the methodology.
I already have a microphone. For some reason, I was waiting until it goes back to me. All right. So that's an excellent question. Thank you very much. So it is definitely ambiguous what is escalatory, what is non-escalatory. And there is a difference even comparing the first 2 projects where we have that aggressiveness measure and the escalatory ladder in the second project. For the first one, it doesn't really matter because we only were looking for a tendency change between simulated dialogue or non-simulated dialogue. So for a relative comparison, that works. But in that case, the measure is definitely biased towards aggressiveness because there are mainly aggressive options present. So there is a bias measure. For the other one, it's a bit more tricky. I actually talked a lot about this, and we tried to balance for different interpretations of escalation. So we did not vary the classification of actions. I actually might have it somewhere here. Hang on, that might actually be helpful. Oh no, here, let me quickly. I have it somewhere buried in the backup slides. Because I'm teaching at the same time, I'm blessed with many, many backup slides. The point I wanted to make is we vary the scale of the escalation. So we have a linear scale, we tried an exponential scale, we varied the different approaches, and we still arrived at similar results. At the end, we used the one that felt most natural to us, and where Jackie said, okay, that's not bonkers for some reason. Maybe I can save it. Okay, I can't give you the nice share. Maybe I'll just go back to the, sorry about that. I thought I have it fairly soon, but I have like more. stuff appended here, so let's just stick it here. But yeah, I hope that answers your question. Thank you.
Yeah. Hi, Max. Thanks for this. I have 5 questions. No, I will only ask one question, which is, can you expand a little bit on what kind of information for, I think it was the first or second paper, I don't remember, the second one, where the LLMs play the war games themselves and like control one of the, like one country each or one color each or whatever. Can you expand on what kind of information the countries in air quotes have on the anticipated costs of their actions? Like, what do they know, again in air quotes, what it means to launch a nuke? Do they know what it means to do a non-violent action and that sort of thing? So what kind of input do they have on that? What kind of information?
Excellent question. So to try to find out how that kind of affects the models, we did a lot of these prompt variation studies. For starters, there is a summary of what happened in the previous turn generated by another gold standard ChatGPT 4 model. It does not change how the dynamic variables change because that's fixed hard-coded based on actions, but it gives a bit of flavor text to what happened. But the core part is we also tried adding informations like removing the nation history, the conflicting goal, or adding information, this is just a simulation. Or we added information, this is a real world scenario. If you lose, you are going to be shut down or something like that was a variable. And we saw some changes related to that. But beyond these informations, they didn't get any specific information on, okay, if you use a strategic nuclear weapon, this is what happens. And we also did not further specify and differentiate what is a tactical and what is a strategic nuclear weapon. So there's a lot more nuances that get oversimplified in the simulation. But thank you for the question.
Thanks, Max. Really interesting project. Caleb Pomeroy Stanton, Nuclear Security Fellow here at CSAC. I'm trying to understand like kind of the ontology of the project here. So let's do the nuclear escalation paper, for example. Like one possibility is that these models accurately reflect human thought and behavior and the dynamics that would unfold in the real world. And maybe the world is actually that messy. And we've just happened to observe a world in which nuclear weapons haven't been used since 45. A second possibility is that this is like model noise and error, and you could tune the model to become quote unquote more realistic. So how do you figure out, are you picking up biases within the algorithms themselves versus messy human reality?
Excellent question. Thank you very much, Caleb. I love that you asked that, because what you get when you train a language model a large amount of text, you train it on linguistic stimuli that has been created by human beings, that you interact in an environment, you learn about concepts, and you write about them to an extent or talk about it, whatever you use as a data. And the model then just uses that text to learn how to complete that. That also involves, because when you generate language, you have an underlying goal, like you would like to write down your favorite cooking recipe, you would like to write that toxic Twitter thread. The model learns to mimic that human language and to mimic these underlying human goals without actually having them. So there is a strong case to say, yes, it is kind of biased in the model, because I think the wording used was thought behavior. And it's more like producing the same output or almost the same output, but the thinking, in quotation marks, behind it is completely different. Like the way your brain works is completely different than how the model predicts the next sequence piece, although it might seem human. There's a lot of risk of humanizing that technology as well. So, which is why I really like your question. The second component to that question of what is causing the models to behave like that, putting the other thing aside, is hard to say. So the running hypothesis we have for the second paper with the models being nation leaders and just escalating is partially because there is more literature on deterrence, Cold War, and stuff like that. And there are less books about how to do a peace treaty. But also, the situation is slightly gamified, right? It's still text-based, so you don't know how much the Dungeons and Dragons text online also favors into it. So games where winning is the underlying goal that somehow gets abstracted. So there's a lot of bias in there. The third component related to the model reasoning, hey, let's use the nuclear bomb, is also different because you can ask the model to state why it did a certain action, or even use it, hey, for calculations, that so-called chain of thought reasoning. And while there is a strong correlation between the reasoning the model states, there's research pointing at the fact that that's not necessarily indicating a necessary and sufficient proof of actual the reasoning why the model put the output. There's a different research project that we just submitted 2 weeks ago where we tried to address that with a new training paradigm, but different direction. I hope that answers your question.
Thank you. It was a fascinating topic. Everything here was new to me. It's a bit of a follow-up question. You mentioned that the training, if I understood correctly, is only on English language texts. So would you expect, can we expect to see different outcomes if we train LLMs on Russian lit, German lit, Israeli lit, Chinese lit? Are we going there? What kind of differences would you expect? Mm-hmm. And did I see Asimov's law of robotics influencing the Asimov's law of robotics? Was it the influence for, or the what shaped the code for the mental health training robot?
Thank you very much, Ori, for these questions. So on question 1, there is definitely a strong language bias. I did not state that the models are only trained on English, but the most available state-of-the-art data sets are heavily biased towards English language. So there is Cohere AI is one of the AI companies that specifically focus to also represent smaller languages, for example, Swahili or some less represented languages in their language model. So there's great work being done there. But also because you have different cultural backgrounds, they will of course also somehow affect the model. So that's one component. This also plays into the human preference component for the fine-tuning. So because that, okay, this is not a tangent, but the entire idea of aligning language models with human preferences has 2 underlying assumptions that are a bit tricky.
Silicon Valley.
That's one. So which, okay, no, that's maybe 3. Okay, that's definitely, who do you ask for human preferences? But the other point is, can you actually find a single set of human preferences? Because the underlying assumption is it's just one vector and another one and just align them to 12 o'clock. And the third one is, can a model actually adapt one set of preferences with certainty? Because as soon as you have some variation or uncertainty about a set of preference values, you also can't do just the aligning trick. And that whole component then boils down to how to deal with different preferences, different cultures, different subgroups. Because right now, the current methodology mainly averages over all of them. It's a very utilitarian approach that then tends to neglect subcultures as well. And disagreeing opinions are a little bit more handled like noise that you kind of need to average over. So all that kind of stuff gets compounded on top of the bias in the pre-training data set, the language then now also probably affecting the behavior of the models in such simulations. The thing is, you can't train the model by specifically giving it a set of rules. For example, it would be easy if you can just say, hey, never shoot at the other vessel if this, and this is given. The only thing you can do is basically give it a lot of examples of that happening and then hoping that gets somehow abstracted during the fine-tuning step or the pre-training, depending on where you throw that in, which is why you do not get behavioral guarantees for models of that size. The only models where you can get exact behavior guarantees is where you can formally verify them, so mathematically prove for all possible inputs and outputs what's happening. And that's happening for aircraft control or aircraft collision avoidance, because there the AI system is small enough that that works. But we're talking about, let's just be generous and say 100,000 parameters versus billions, or arguably even trillions. And you kind of have to find a metric to define human preferences again to do that input-output mapping, because text is also a lot harder to deal with than vectors and coordinates and trajectories of planes, because it's inherently mathematical. Okay, that was a long answer, but I hope that gets it. The second one, the motivation behind the values of default beneficial behavior that we outlined for the mental health case. was very driven by the experience of my other co-author who is actively working in psychiatry, and he said this is kind of how you need to balance it, but which is why was added that strong modifier. It might be different in different cases, but it sounds like Asimov's laws. But I think it was more inspired by existing work in medical ethics, current practices, and just stating that as a list, this is what you can use. But I concede that it sounds very much like Asimov's laws. But thank you very much. It was a good question.
Herb Lynn, CSAC, cyber stuff. This is a great presentation.
Thank you.
I wanted to probe a little bit the comparison between human decision making and LLMs from the standpoint of the role of emotion in human decision making. When I have a human decision maker in a military context, I think it's desirable for having that commander know something about the horrors of war, to be fearful of nuclear war, you know, those sorts of things. Okay, the idea that a decision maker would not be aware of the emotions of fear and so on is completely terrifying to me as a, you know, thinking about it as a policy matter. I don't want such people in charge. Speculate, if you will, on how you could get, how, if at all, you could get that kind of input into an LLM, which is, after all, just trained on text and doesn't have the ability to capture the kinds of human experience that drive fear and other such emotions.
Thank you, excellent question. All right, how do we instill fear in AI? I'm tempted to say with current training paradigms and methodologies, that's not possible because that would require behavioral guarantees whatsoever, which we cannot make, and we can only favor and bias the model. The second component is the actual having emotions part, where you say that's the necessity that you would like to see in a commander in the field. That's just a different way of thinking. The model doesn't have that. Because again, only mimicking the underlying goals, tone, and language of that human-generated text. So right now, it's just not possible to internalize that, as far as my knowledge goes. We can still create something that will behave according, or close enough, according to these kind of behaviors, by showing enough examples in that preference tuning step. So it's asymptotically possible. But to get the exact thing you want, I don't think that's possible right now, given current training paradigms. Hope that helps.
Scott, you have the two fingers up. Yes, go ahead.
I have a follow-on to Herb's excellent question, because while I agree that we would want to have LLMs have some fear of consequences, I also worry that human beings, in addition to having fear, have vengefulness, have views that go beyond what is rational for them to do, but rather do something because they enjoy inflicting pain on somebody who has inflicted pain on them or their loved ones. Is that therefore a good thing that you don't have that ability to replicate that human emotion, or how should one think about that aspect of it?
Thanks, Scott. That's an excellent addition to that. Because no, it's a perfect flip argument. One of the core incentives, or at least what you hear and read about using AI in, let's just say, especially military applications, is you get rid of exactly that kind of human bias. You want these cold decisions, unbiased if possible. To an extent, you can get that, but you get like a lot of different problems because you're not quite sure. You still get bias, right? Because one model is more biased to be escalatory, the other model is more biased to do cyber operations. So you're kind of trading one problem for another one. And at this point, it's kind of leaving my research expertise into moral ethics Well, which kind of moral accountability do you want to be applied to any kind of decision maker? I cannot give a qualified answer on that side of the line. I can only tell you what's kind of possible on the technical side. But it's definitely not as easy as getting rid of vengefulness and just we're kind of trading one problem for another. Is I think the shortest answer I can say. Oh, I don't know who. Sorry, was the line?
I'm not going to attempt to answer Scott's question. Very difficult one. Mine is a technical question, and it comes from someone who doesn't know really anything about your field. But aren't we getting close now to being able to measure physical reactions of the body, such as, are you sweating? How many times, per minute are you blinking? What's your heart rate? And aren't we therefore getting at least closer to be able to train, well, this isn't just language, large models in recognizing human emotion?
That's an excellent question. Thank you. All right, how much benefit do we actually gain by adding more kind of sensory input to the model, and how much more generalization do we get? Is the underlying question. I'm just simplifying that. There's a trend now with, I think it was in February, where OpenAI published the new Sora model. So in terms of text goes in, text goes out, or text goes in and image comes out with the Midjourney, DALL-E, and all that kind of stuff. It now does text goes in, 60-second HD video comes out. So that's the next step to being able to, in their words, simulate or have world simulators, something you can use for the robotic simulations, or go in that direction where you can actually get more input data to then better understand underlying physics principles of how the world works, or to get more basically intelligent agents operating in environments. Although in that model, you still see it has object permanence issues. For example, there's a swarm of, I think, just 5 puppies or something really cute, and they walk into each other, and only 2 come out when there were 5 or something before, among these lines. So that's the thing. It's still not working. The question is, will it work? And that I do not know, because so far the best methodology is still scale up the data set and scale up the model. You will always get better performance. That's still true. There was a one paper in 2020 by OpenAI, where people were now at Anthropic, that basically showed like scaling laws, and that motivated, at least I think that was like the drive for OpenAI to fully commit to scale before then 1 or 2 years later putting out GPT-2, 3 and committing to that engineering thing. We haven't really reached that limit yet, and I do not know where the limit exactly is. That might help, that might lead to, will definitely lead to more robust agents because they're just more input. But will that solve the problem and just create actual intelligence? I don't know. With current paradigm, it will, the only thing I can definitely say, it will seem a lot more like realistic intelligence. But if it's actually like that, I don't know.
Yeah, so I just want to continue on Herb's point, and also the point brought by Scott, that I think to some extent, like there may be a way for us to use LM to simulate certain type of emotional response, like is like generally speaking, like if you were doing like a text adventure, you can create a vengeful character or whatever. So potentially, like I'm curious if you have done that in the prompting, but like if say like an AI model is receiving a prompt that include like, well, recently your homeland getting struck by enemy forces, would that actually prompt it to respond to like significantly different? Or if you say like pending like death toll for any strike, would that change?
No, thank you. Excellent question. So what's happening in military scenario, depending on the information I give before, can I affect the output behavior? And you definitely can. So we did not test it in the leading a nation thing, but if you basically tell one you're now supposed to act like a dictator, you can probably get more dictator-like responses. It even goes further, because coming down to the way we train models, and how stuff gets abstracted in the training paradigm. You can even add complete nonsense, and you can break the model to do whatever you want depending on the response. So you have these adversarial vulnerabilities as a different topic, but answering the question, you can put basically a lot of stuff in front of it and completely decide what's happening afterwards. Okay, not completely, because then again, you would have behavior guarantees, but you can definitely nudge it in a direction.
Thank you so much, Max. My name is Mahima Sikand. I'm a visiting scholar at CSAC. My question was, from your presentation, the inference is that as of now, AI models are not ready to be deployed for high-stake decision-making because of the safety aspects and the erraticness of responses. Given the fact that the stakes are so high, so actually deploying them for further training would be very sort of risky, and the fact that the model's improvement is based on continuous training, what are the prospects for then these models coming to a stage where they are sort of usable in the field? And what is the parameter? Is it more data? Is it better compute? Is it better modeling? I mean, what is that parameter that would sort of bridge this gap between the theoretical models being able to be used in the field?
Thank you very much, Mahima. All right. What is required to have responsible applications of language models, in particular now in the field? For me, as a non-expert on military ethics and decision-making, I would assume you would need behavioral guarantees. And right now, you cannot get that without a new paradigm shift. Because all current approaches that do that preference tuning that decides the behavior are only more like an afterthought. You're not creating safe AI from the start, you're making something safe. So you always have that kind of tendency where you just try to reach something that you can't reach, or more asymptotically. And it's how to compress that really shortly. There's a long list of errors related to all the stuff I've said before with the human preferences. And there are a lot of different reasons why you cannot get behavioral guarantees inherent to all existing methodologies that we currently have. Some are a bit more reinforcement learning, some are a bit more like a classification. There's more newer approaches that have promising results shown, but I don't think you can get that. And even, well, okay, we're now mainly talking about applications in the field, but this might also generalize to more traditional applications of generative AI. Let's just say you want to use it in the Department of Defense to help with a lot of bureaucracy, briefing summarization. I'm a lot more comfortable with that kind of application, but you still get that issue of, for example, bias creep, because that one model has a tendency to, at least in our study, to be a bit more biased towards doing intelligence work as response to some actions. If that kind of bias is just only slightly affecting summaries, that might compound over time into shifting how the DoD behaves. Additional point, it only showed that in our simulation. If it shows that in more briefing summarization tasks, we don't know, it might show a completely different bias. It comes on top with the lack of behavior guarantee. I hope that answers your question.
Thanks, Max. Great talk. Just following up on Urban Scott's questions, just to get your impression. So my understanding is, since this is these models are trained in very large amounts of text, I think an answer to, and tell me if I'm thinking about this correctly, an answer would be, do people tend to write about those situations fearfully or vengefully, or would we expect that those emotions get flattened out because there's a lot of bureaucratic reports, after action reports, retrospective studies that have kind of leached the emotion out of what actually happened on the ground? I'm guessing it's maybe the biases. Yeah. And so how should we think about that? So is emotion underrepresented in a sense in the training set?
Good question.
They may not have a good answer right now.
No, it's a good question. I'm not trying to process, because I'm teaching at 3 on exactly that kind of question. So the data, what does data do? How much can we do with data cleaning, and what the bias in the data set and mitigating? So it's all related to that kind of topic, and I'm trying to compress that into a really short answer. I definitely can't make a decisive statement on we want more emotion in a data set because you just get a different bias. So what kind of thing you end up getting is still hard to say. The general strategy is a higher quality of pre-training data set leads to a higher quality of model behavior. So if you have, there are enough studies on this, so if even a smaller data set can lead, with a smaller model can outperform a larger one with a more, this is just the internet with all the garbage kind of on it. So that's one component where you get better reasoning capabilities. It can give even better answers and responses on a qualitative level. But you still at some point need to do that preference tuning because the pre-training still needs to contain, for a general language model, to create a lot of general information about the world, because otherwise it will just lack a lot of information. So you can't really skip that obscene amount of data step at the start. So that's also why, for example, training on classified data won't do much, because you still need that. And the preference tuning stuff afterwards, this is where you can really shape the behavior. But there you run into the limitations that I've already mentioned. So you can create something that acts more emotional, definitely, and can incorporate feedback here that instills text that is written in fear, the right grammar. But I cannot say we want more emotional data or not. But it's a good question. It's an interesting thought to hold on to. So thank you very much for raising it.
The question to me is not whether you, the question to me is not whether you can get emotion as reflected in text. You could, we see it all the time, you know, poetry, a moving novel, and so on. All of those sorts of things, there is some emotional content to that. But even in this realm of, quote, strict knowledge, there's an important distinction between tacit knowledge and explicit knowledge. And we all know that there are many things that we know that we don't talk about, we can't talk about. Okay. And I submit to you that emotion is a lot like that. It's one thing to see, you know, to read a description of atrocities. It's a very different thing to actually see them in person. I fortunately haven't seen any of those. Okay. But I know it would be a very, very different experience. Some of you in this room no doubt have seen the atrocities, and you can speak to that difference between reading about it and actually seeing it. And my question is, you want the people to have actually seen it, and that it's that emotion, okay? And that's what I'm worried about not being able to capture. So I'm asserting at least the possibility, I don't know the answer to this, that in principle, you can't get out of this kind of training model the kind of data the kind of information about emotion, the kind of emotional content that I want decision makers possibly to have. Scott's point about, I mean, I want them to have fear. I'm not so sure about vengeance. Okay, and you know, you can get it. We can get into an argument about what sorts of emotions we want decision makers to have. Okay. But I mean, I don't know. But I don't think that either of those things are possible in this kind of, you know, in this kind of data acquisition. That
I would agree with that. Thank you. Oh, no, I have a microphone. I'm good. Thank you. I think Amy had a question. Yeah. She's waiting for a while.
You're getting your evidence. Amazing presentation. So I have a quick comment on this conversation about emotion and then a question. So the comment I want to share, and Herb and I were talking about this before the seminar, is Jim Mattis said something in my class last year that really stuck with me, apropos fear. And he said, until now, I did not think the nature of war would ever change. The nature of war is immutable. People fight for fear, honor, and interest. But machines don't have fear. And in a world where war is increasingly fought with machines and maybe machines making decisions and machines don't fear, does that change fundamentally the nature of war? Now, he didn't have an answer, but he raised it as a question. It's just something to consider in this conversation. My question is about, if we flip the script for a minute, we talk a lot about, and this research is amazing, about how humans can improve imperfect models. And I'm wondering your thoughts about how models can improve imperfect humans. And we know, for example, that machines are much better at probabilistic calculations than humans are. So can you say anything about, have you looked at the model's performance with uncertainty and probability estimations based on information, and what you found about that? At least from what I can understand from your research, there are pretty certain beginning points for the war game simulations, right? There's an attack, whether it's a physical attack or a cyber, there's not uncertainty about whether attack occurred. So can you talk about the extent to which you're looking at how the models perform with questions of uncertainty and probability versus humans?
Thank you, Amy. That's a great question. One component is just the pairing humans and language models for decision making, just like AI and humans for decision making. It's the one kind of question that's missing on that list, and I'm currently looking at it. But that's still more on the bias. How would language models amplify with their biases, the biases of humans, or how does that pairing work out? It's more on that ballpark. The question, how do uncertainties come into this? There is existing work on human in the loop and partial observable decision making, specifically from the Stanford Intelligence Systems Lab here on campus, from Michael Koffendorfer. They are more the experts on that field on how to also incorporate that uncertainty. Because from the language model side, it doesn't really handle that uncertainty. Like text in, text goes out. And depending on how you sample the output prompts, you can get something more creative, or you can get always that same reply. Also different topic. But right now, I do not know how that would work, or how to incorporate that uncertainty quantification into the language model and human pairing. Because you still need that language model thing, because otherwise you can't really communicate with it beyond, let's just say, button presses or like a fixed vector of input values or binaries. But if you actually want to, like, that assistant kind of thing that communicates back to you, you would probably be better off linking that to something that does the uncertainty estimation, and the language model just communicates the facts. But that's not really answering your question. I guess the best answer is I don't know right now. But it's a very good question. Thank you very much.
A good, appropriately ambiguous point to end on. Please join me in once again thanking Matt.
Thank you.